number 46. Identify the polyatomic anion, including its proper charge, in each of the following ionic compounds. So you're given two formulas for compounds. How many protons and electrons are present in each polyatomic anion? That's part B. Okay, first part A. Let's look at both of these formulas. Now, these are ionic compounds. Ionic compounds, of course, have a cation, a positive cation, and a negative anion. Now, the cations for ionic compounds are almost always going to be metals. And so when you look in these formulas right here, you can identify the metals right there. You see potassium right there is K, and then calcium right there is Ca. Now the rest of it is going to be the polyatomic anion. So you got BrO3 and HPO3. So here we can go to this table 3.5 to figure out what the name of the anion is. Okay, so how about the BrO3? Let's go to where's BR? So BrO3. It's actually not in this table. Okay, BrO3. So A, and then B, and then C. Let's just make our little table here. So the cation in A is going, which we only have A and B. I'm sorry. The cation is going to be K. Okay, we'll figure out the charge in a second. And the cation in B is going to be Ca. Now the anion in A is going to be BrO3. We'll figure out the charge in a second. And then the anion is HPO3. Now HPO3, I don't even see that under the phosphorus section. So how do we figure out what these guys are, what the charges are? Well, the way we do it is by figuring out the charge on the other one, because charges have to balance. Okay, so if we know what the charge on the calcium is, or the potassium, then we can figure out what the charge on these guys are. So let's go find the charge on potassium and calcium. And here, you go back to the periodic table, figure 3.2. This kind of tells you what charges atoms like to form if they form ions. And potassium is in the +1 column. Okay, it's in group 1A, and calcium is in group 2A. So anytime potassium forms an ion, it's a +1 ion. So here, right, +1. And then the calcium, anytime it forms an ion, it's a +2. Now, since charges have to balance, and you can see in the formula that for every one potassium, you got one of these, then the charge on that guy must also be the same magnitude but opposite. So minus. And likewise, you got one calcium in the formula, and then one of these guys, so it must be -2. Okay, so that answers the first part. We've identified the polyatomic anion in each of the, including the charge in each of the following compounds. Now we don't know the name, and the name isn't given to you in the textbook, but I'll just tell you that this is called bromate. Okay, a bromate. Okay, kind of a strange name. Okay, and then okay, this one right here, that's called hydrogen phosphite or biphosphite. Okay, hydrogen phosphite. Okay, or biphosphite, whatever. Anyway, it's not important what the name is. The next part in this is we need another periodic table for the next part, so we'll use this one. The next part asks how many protons and electrons are present in each polyatomic anion. Okay, in each polyatomic anion. So here are the anions. Okay, so how many protons and electrons are present? Well, let's look at the first one. So bromine is element number 35. Okay, bromine has 35 protons. So up here, you know, let me just copy this down there. We need a little bit more room. So copy. Let's paste it right there. And bromine is going to be element 35. So I'll say, so as far as the protons go, we're going to have 35 from the bromine. Okay, what about the 3 oxygens? Where's oxygen at? Oxygen is element number 8. Each oxygen has 8 protons, but you got 3 of them. So plus 3 times 8. 3 times 8. And if you calculate that, that's going to be, 35 plus 24 is 59. So that's how many protons are present in this guy right here. Okay, now electrons, we could do electrons the same way, or we could just say, the electrons are always equal. Okay, the electrons, you got electrons on the bromine, electrons on the 3 oxygens, and electrons always equal protons, but the charge right here tells you have 1 extra electron. So you have 59 from the 4 atoms altogether, plus 1 extra electron. So it's going to be 59 plus 1 extra electron, because it's a -1 charge. So it's going to be 60 electrons. Now let's do the other one. The hydrogen phosphite. Okay, let's make a little bit more room for that.
It's not lunchtime yet.
So protons and electrons. Okay, now we got hydrogen, phosphorus, and oxygen. Hydrogen is element number 1. So you got 1 proton. Okay, plus you got 1 phosphorus. Phosphorus is element 15. So it's going to be 1 plus 15. And you got the 3 oxygens. So plus 3 times 8. You add that up. And so it's going to be 16 plus 24 is 40 protons altogether. Now the electrons is going to be the same thing. You're going to have the 40 plus 2 extra electrons. So that equals 42.